So we want to determine if this sequence converges or diverges. So to determine this for a sequence, we want to know what happens to the terms in the sequence as we approach infinity. So we're going to take the limit as n goes to infinity of 4n sine 3 over n. Now, as we look at this, a couple things we can see. There's two different parts to this, and this first one, 4n, as we approach infinity, approaches infinity. The second one, the sine of 3 over n, well, as n approaches infinity with a fixed numerator, denominator becoming larger and larger, that's going to approach 0, so we're going to have the sine of 0, which is 0. So we have an indeterminate form, infinity times 0. That should lead us to L'Hopital's rule, because L'Hopital's rule helps us with indeterminate forms. However, to use L'Hopital's rule, we need to have the form infinity over infinity, or 0 over 0, and we have infinity times 0. So before we can use L'Hopital's rule, we're going to need to do some algebra, doctor it up a little bit so it's in the right form. So what I'm going to do is leave the sine 3 over n there and divide it by 1 over n. So and let's put the 4, I'll just leave the 4 on the top. So you can see here, if I took the denominator and I inverted and multiplied, I multiplied it by n over 1, it would be my original thing. And so this is equivalent to my original, but now as we let n go to infinity, the numerator goes to infinity, and the denominator, 1 over n, fixed numerator, denominator becoming huge, also goes to infinity. So it's in the right form to use L'Hopital's rule. So that's what I'm going to do. I'm going to move down onto the next line so I've got enough room to compute that. So I have the limit as n goes to infinity of, we take the derivative of the numerator, the derivative of, we just got the 4 there, sine of 3 over n will be cosine of 3 over n, but then we need to multiply by the derivative of the 3 over n, which is going to be negative 3 over n squared, because 3 over n is like 3 to the negative 1, so if we did power out in front, it will make it negative, decrease the power by 1 will make it n to the negative 2. Alright, and then we divide that by the derivative of the denominator, which is going to be negative 1 over n squared, for the same reason, that n to the minus 1, power out in front will make it negative, decrease the power by 1 will make it to the negative 2, and then we can rewrite it without the negative exponent. Alright, so now let's see what we have. Let's take this denominator and invert and multiply here. So we're multiplying by the reciprocal, and the negatives will make a positive and the n squareds will cancel. So now let's see if we can take the limit, what we have left. So we have this 4 times a 3, which is 12, and the limit as n goes to infinity of the 3 over n is 0, and the cosine of 0 is 1. So this converges, and it says if it converges, compute the limit, and the limit is 12.